Okay, ready to dive into the world of quantum computing.
Sounds good.
You sent over this doc, Quantum Solutions, Practical Applications Across Industries.
Yeah.
It looks like we're going to be exploring how quantum computing could change just about everything.
It's pretty wild stuff. We're not just talking about faster computers.
Hmm.
Quantum computing is a completely different way of approaching problems.
Okay, so like a whole new dimension of computation.
Almost.
Wow.
Mhm.
Well, chapter 1 of the doc dives right into the fundamentals. Starts by talking about these things called qubits. I know computers now use bits, which are like a 0 or a 1,
Right.
but qubits are different.
Absolutely. Think of a qubit like a coin.
Okay,
It can be heads or tails,
sure.
but it can also be both at the same time.
Both at the same time. How is that even possible?
It's a mind-bending concept
Hmm.
called superposition. It allows quantum computers to explore a ton of possibilities simultaneously.
It's not checking each possibility one by one. It's like checking all of them at once.
Exactly.
That's incredible.
Yeah.
But the document also mentions entanglement, which sounds even weirder.
Yeah, entanglement is one of the most bizarre things in quantum mechanics. It's like two of these qubits are linked,
Okay.
but in a way that just doesn't make sense in our classical understanding of space and time. You can separate them by a huge distance, like across the universe, but when you measure one, it instantly affects the other.
No way. So they're connected no matter how far apart they are.
It's like they're communicating faster than the speed of light. This interconnectedness is key for a lot of powerful quantum algorithms.
I could see why people are saying quantum computing has the potential to change everything. But chapter 1 also talks about the challenges of actually building these machines.
Right.
Controlling those delicate qubits and keeping them stable sounds super hard.
Imagine trying to build a house of cards on a rocking boat. That's kind of the level of precision and stability that's needed.
Wow. So manipulating these particles at the atomic level is a pretty delicate dance.
It is, but the progress being made in quantum hardware is astounding.
With those mind-boggling basics in mind, Chapter 2 jumps into healthcare. It suggests that quantum computing could totally change how we approach things like drug discovery and genomic analysis.
One of the most promising applications is simulating molecular interactions.
Hmm.
Classical computers really struggle with that,
But
just
Dorothy-
because it's so complex.
Right.
But quantum computers can handle it much more effectively. This could lead to the development of new drugs and therapy.
That makes sense. The document mentions VQE and QPE,
Yeah.
variational quantum eigensolver and quantum phase estimation.
Those are algorithms specifically designed for quantum computers.
Can you break those down a little bit?
Sure, VQE is really useful for simulating molecules
Okay.
and understanding their properties. Researchers are already using VQE to study things like the energy levels of molecules,
Right.
which is key for designing new drugs and materials.
So we're not just talking about brute force calculations here. These algorithms are really tailored to take advantage of quantum mechanics.
Precisely.
And what about QPE?
QPE is another powerful tool, especially for tasks like factoring large numbers, which, has implications for breaking certain types of encryption. But it's also important for simulating quantum systems more efficiently.
You highlighted a study in your notes where researchers used quantum annealing to understand the structure of proteins. This seems like a big deal for personalized medicine.
It is. Understanding how proteins are structured is critical for developing new treatments for diseases.
Right.
And quantum computers can analyze your unique DNA
Wow.
and help tailor treatments just for you. Imagine medicine that's truly personalized,
Wow.
targeting diseases at the molecular level.
With fewer side effects, hopefully.
Exactly.
Now, I think people might be wondering how all this quantum magic applies to something like, say, managing their investments.
Mhm.
That's where Chapter 3 comes in.
Right.
It focuses on quantum computing and finance, and it suggests that Wall Street might never be the same.
Well, the financial world is all about optimization,
Hmm.
maximizing returns and minimizing risk.
Okay.
Quantum algorithms like QAOA, the quantum approximate optimization algorithm, can analyze massive data sets and make calculations that would take classical computers years, if not centuries.
Oh, wow. So, like, our portfolio could be constantly optimized in real time.
Imagine that, adapting to market fluctuations with incredible speed and accuracy.
That sounds almost too good to be true. The document also talks about using quantum machine learning for fraud detection,
Yeah.
analyzing huge data sets to find those unusual patterns.
Right. Financial institutions are constantly fighting fraud.
Mm.
And quantum computing could be a total game changer. By identifying subtle anomalies in these huge data sets, quantum algorithms could help prevent financial crimes.
Before they even happen.
Exactly.
It seems like every industry we look at could be disrupted by quantum computing.
Yeah.
Chapter 4 takes us into the world of manufacturing and supply chains. Things are about to get a lot more efficient.
Manufacturing and logistics are incredibly complex. Countless variables and constraints. Quantum computing can help us tackle these challenges in new ways.
They mention QUBO models in the doc.
Yeah.
Quadratic, unconstrained binary optimization.
It sounds a little intimidating.
It does. Can you explain what they are?
Think of QUBO as a way of translating these complex real-world problems into a language that a quantum computer can understand. Like, imagine a factory floor.
Okay.
Multiple machines, each with a set of tasks and deadlines. QUBO can help formulate this problem so that a quantum computer can find the most efficient schedule.
So it's like having a super intelligent scheduler that can juggle all these tasks and find the best solution.
That's a great way to put it.
And that's just one example.
Right.
So it could be used to optimize logistics and supply chains, finding the best routes for delivery trucks, dynamically adjusting inventory levels.
Absolutely.
It could have a huge impact on global trade.
For sure.
The COVID-19 pandemic really showed how fragile our supply chains are. Could quantum computing help us build more resilient systems in the future?
I think so. Imagine supply chains that can adapt to disruptions immediately. Rerouting shipments, adjusting schedules,
Right.
minimizing delays. Quantum computing can help create systems that are more robust and adaptable.
So far, we've talked about how quantum computing could impact healthcare, finance, and even manufacturing. But what about climate change? Chapter 5 gets into the role of quantum computing in energy and sustainability.
It's a really important area.
It seems like it could be a powerful tool in our fight for a greener future.
It's fascinating how quantum computing can help address some of humanity's biggest challenges.
Yeah, like the need for clean energy. And Chapter 5 really dives into that. It highlights how quantum computers could lead to big breakthroughs in renewable energy technologies.
One area where quantum computing has a ton of potential is the development of new materials. Imagine solar panels that are twice as efficient, or batteries that can store energy for weeks instead of days.
Wow.
Quantum simulations could help us design those materials at the molecular level.
So like optimizing them for peak performance.
Exactly.
The document specifically mentions the role of quantum chemistry in this field.
Right.
It highlights a study where researchers used quantum computers to look at the behavior of catalysts,
Yeah.
ones that could potentially make hydrogen production a lot more efficient.
That's a great example. Hydrogen is a clean fuel for the future.
Right.
But producing it sustainably is a challenge. Quantum computing could help us design catalysts that need less energy and create less waste.
And it's not just about producing clean energy, it's about using it smarter too.
Right.
Chapter 5 suggests that quantum computing could optimize entire energy grids,
Yeah.
making them more responsive to changes in supply and demand.
Imagine a world where energy grids can seamlessly integrate renewable sources,
Okay.
like solar and wind, adjusting in real time to changes in weather patterns and consumer behavior.
Wow.
That's the kind of intelligent energy management that quantum computing could bring.
It could help us create a truly sustainable energy ecosystem.
I think so.
Okay, so we've talked about healthcare, finance, manufacturing, energy. It seems like quantum computing is touching everything. But one area that feels really important is security.
Yeah, for sure.
Chapter 6 dives into cryptography and cybersecurity.
Right.
And it paints a slightly unsettling picture.
Well, it's true. Quantum computing presents both a challenge and an opportunity in cybersecurity.
Okay.
On one hand, it could break the encryption methods we use to protect data.
The document keeps bringing up Shor's algorithm.
Right.
Can you explain why this algorithm has security experts worried?
Shor's algorithm is specifically designed to factor large numbers. That's super hard for classical computers to do,
Okay.
but relatively easy for quantum computers. And that's a problem.
Right.
A lot of our current encryption, like the RSA algorithm, relies on the difficulty of factoring large numbers.
So it's like having a master key that can open any digital vault.
Yeah.
That's a scary thought. Are we just sitting ducks, like waiting for this quantum apocalypse where all our data is vulnerable?
Not necessarily. The threat is real, but the cybersecurity community is working on solutions. The document mentions post-quantum cryptography, or PQC. It's about developing new encryption algorithms that are resistant to attacks from both classical and quantum computers.
So like building a new generation of digital fortresses with walls that can withstand quantum attacks.
Exactly.
And organizations like NIST, the National Institute of Standards and Technology, are leading the way in standardizing these new methods.
That's right.
But Chapter 6 also talks about using quantum mechanics itself to create unbreakable codes. That sounds like something out of science fiction.
It's pretty mind-blowing. Quantum key distribution, or QKD, uses the principles of quantum mechanics to exchange encryption keys in a way that's provably secure. Any attempt to listen in on the key exchange would instantly change the quantum state of the particles,
Wow.
which would alert both parties.
So it's not just about having a strong lock. It's about having a lock that sets off an alarm if anyone even tries to pick it.
Exactly. QKD offers a level of security that we just can't get with classical cryptography.
So quantum computing is shaking up cybersecurity in a big way. Now, Chapter 7 takes us into artificial intelligence and machine learning, two technologies that are already changing our lives.
Yeah.
It suggests that quantum computing could take them to another level entirely.
It's an area that's ripe for disruption. AI, especially machine learning, is all about analyzing huge amounts of data to find patterns and make predictions.
Right.
But classical computers can really struggle with some data sets. They're just too big and complex.
So quantum computers could provide the power to tackle those massive data sets.
Exactly. And it's not just about speed. Quantum algorithms can analyze data in totally different ways.
Yeah.
That could lead to insights that would be impossible for classical computers to find.
The document specifically mentions supervised learning.
Right.
That's where we train AI models on labeled data.
Right.
It says that quantum computers could really speed up this process,
Yeah.
leading to models that are more accurate and efficient.
Imagine training a medical AI on millions of patient records to diagnose diseases with incredible accuracy.
Okay.
Or a financial AI that can predict market trends with amazing precision.
Wow.
Those are just a few examples of how quantum-enhanced supervised learning could revolutionize things.
But AI isn't just about analyzing data that's already there. It's also about learning and adapting to new information. The document talks about reinforcement learning,
Yeah.
where AI agents learn by trying things out and interacting with their environment.
Right.
How could quantum computing affect that field?
Reinforcement learning is super powerful, but it can also be really time-consuming. Quantum computing could speed up the learning process tremendously, allowing AI agents to learn much faster.
So we could have robots that can learn new tasks in a few hours instead of days.
Exactly. Or self-driving cars that can handle tough situations much better.
Like driving in heavy traffic or avoiding unexpected obstacles.
Right. The possibilities are huge and incredibly exciting.
Chapter 7 also gets into quantum neural networks.
QNNs.
Yeah, those sound like a whole other level of AI.
They are. QNNs combine quantum computing with artificial neural networks. You know, the ones modeled after the human brain.
Yeah.
They have the potential to process information and make connections differently than classical neural networks.
It's like we're creating a new type of intelligence. One that doesn't just think faster, but thinks in a completely different way.
That's a great way to think about it. We're just starting to understand the potential of QNNs. But it's clear they hold a lot of promise for AI.
Okay, so we've looked at healthcare, finance, manufacturing, energy, security, and AI. What else is left? Well, Chapter 8 goes into transportation and logistics.
Oh, yeah.
It suggests that our commutes and deliveries are going to get a lot smoother.
Transportation and logistics are incredibly complex systems. So many variables.
Yeah.
Quantum computing can help us optimize those systems like never before.
Okay.
More efficient routes, less congestion, and faster deliveries.
The document talks about using quantum annealing to solve those optimization problems.
Right.
Like finding the best routes for delivery trucks or managing traffic flow in a city.
Imagine a world where delivery trucks always take the most efficient routes.
Okay.
Using less fuel and delivering things faster.
Or a city where traffic lights adapt to traffic patterns in real time. Shorter commutes for everyone.
Absolutely. That's how quantum computing could transform transportation.
And of course, we can't talk about transportation without talking about self-driving cars.
Right.
The document says quantum computing could be a key part of making autonomous vehicles safer and more reliable.
Self-driving cars rely on a ton of data from sensors and cameras to navigate.
Right.
Quantum computing could help them process that data faster and make decisions more efficiently. Smoother rides and safer outcomes.
It could also help them handle more complex scenarios, like navigating heavy traffic or reacting to unexpected obstacles.
Exactly. Quantum computing could be what unlocks the full potential of self-driving cars.
Okay, so we've covered healthcare, finance, manufacturing, energy, security, AI, and transportation. It feels like quantum computing can do just about anything. But Chapter 9 takes us even further into the future with quantum networking and the idea of a quantum internet.
Yeah, that's where things get really interesting.
Yeah, it feels like we're on the verge of something huge in the world of communication.
Hmm.
The internet changed how we share information, but a quantum internet could be even more revolutionary.
The document paints this picture where data is transmitted using quantum mechanics.
Right.
Unprecedented speed, security, and efficiency. It sounds almost too good to be true.
It's a bold vision, but the science is there.
Mm.
The key is quantum entanglement.
Right, that spooky connection we talked about earlier.
Yeah. Remember how those particles can influence each other instantly no matter how far apart they are?
Yeah, that's still mind-blowing to me.
Well, imagine using that connection to send data. Instead of bits over wires or radio waves, we could use entangled particles to teleport data.
Teleport data, like instantly. It sounds like science fiction. But the science behind quantum teleportation is real. We're not physically moving matter. We're transferring the quantum state from one particle to another.
Okay.
And this could allow for near instantaneous communication.
But wouldn't we need some way to extend the range of entanglement?
You're right.
Those connections can be pretty fragile.
That's where quantum repeaters come in.
Okay.
Think of them as booster stations for entanglement. They help us extend those connections over longer distances.
So it's like building a chain of entangled particles, and each one extends the network further.
Exactly. And each link in the chain is super secure thanks to quantum mechanics. Any attempt to intercept the data would change the entangled state.
Right.
And alert both parties.
That's incredible. But building a quantum internet for the whole world seems incredibly difficult.
Yeah.
What are some of the challenges?
Well, we need better quantum devices. The qubits we have now are still delicate and prone to errors. We need more stable and reliable qubits.
So ones that can operate at higher temperatures and withstand the demands of the real world.
Exactly.
The document also mentions standardization. So if we're going to have a global quantum internet, everything needs to be compatible.
That's right. We need universal protocols so that all these different devices and networks can talk to each other.
So it's not just about the hardware, it's about the software and the infrastructure too.
It's a massive task. We need physicists, engineers, computer scientists, policymakers, everyone working together.
Speaking of challenges, Chapter 10 of the document steps back a bit and looks at the big picture for quantum computing.
Right.
It acknowledges that we're still in the early stages, the NISQ era.
Noisy intermediate scale quantum.
Yes.
Quantum computers are still limited.
The document seems to emphasize the need to not just build bigger quantum computers, but also create new algorithms that take advantage of what they can do.
That's a critical point. We have some powerful algorithms like Shor's and Grover's.
Right.
But we need many more to tackle all the different problems we're interested in. And these algorithms need to be designed to use the principles of quantum mechanics.
So it's not just about raw computing power. It's about finding new ways to apply these quantum properties.
Exactly.
Chapter 10 also brings up some ethical concerns.
Yeah.
Like any powerful technology, there's potential for misuse.
It's important to talk about these issues, like equitable access. We need to make sure that the benefits of quantum computing are available to everyone.
And there's the concern about dual use.
Yeah.
The possibility that this technology could be used for things that could harm people.
That's a real concern, but that doesn't mean we should abandon the technology entirely.
Right.
We need to develop safeguards and regulations to ensure that quantum computing is used ethically.
It feels like we've only scratched the surface of this topic.
Yeah.
From those weird qubits and entanglement to the potential of quantum computers and a quantum internet, this has been an amazing conversation.
It has, and the most exciting part is that we're just at the beginning. Who knows what we'll discover in the future?
Well, I can't wait to find out. What are you most excited about? And what worries you the most about this quantum future?
I'm incredibly excited about the potential for quantum computing to solve problems like climate change and disease, but I do worry about it being misused or making inequality worse. We need to make sure it's used for good.
I totally agree. That's a responsibility we all share. Well, that brings us to the end of our deep dive into quantum computing.
It's been a fascinating journey.
If you want to learn more about some of the topics we talk about today, you can find links in the show notes.
There are some great resources out there.
Thanks for listening. We'll catch you next time as we continue to explore the world of tomorrow.